So then carbon, oh wait, no, that's not carbon, copper and iron. So that's a transitional metal with non-metal. So
Yeah.
that would be an ion. So then it would be copper iodide.
Do we know copper's charge off the periodic table? You said he's a transitional, or copper, did I spell wrong?
Oh, I was like, what? I was like,
Four.
Okay, that confused
My
me.
bad.
Okay, so then, yeah, we don't know it. So then,
You
but
figured it out.
iodine has just a negative,
Mm-hmm.
so then it has to be just positive.
Yeah. And then iodide, right?
So tell me again the bracketing reason.
We use parentheses with transitionals because they have multiple playing cards. That's how I view it. I view all these
So
elements.
you really only use the brackets with the transition.
Yes.
Okay.
We know him, we know him, we know him, and we know those guys.
Okay.
All these others, they have multiple playing cards. I mean, you can look at some of those, like all those numbers
Yeah.
right there. Those are all some of their possibilities.
Okay.
And like, especially some of
So,
them.
but why do these have like possibilities?
Sometimes they're different.
So then how do we like?
Typically.
there
Typically
being
1
ones?
plus, typically 2 plus. Actually, all of those are usually those. It's sometimes like carbon's different. It depends. Sometimes, you know, it.
Cause like right here where it's normally gonna be.
Some of them just vary, but normally carbon's either a 2 or a 4. Nitrogen is normally a 3. That's what the black ones are, the ones that it normally is. But it can also be different ones. Oxygen is normally a -2. Fluorine is usually -1. So just as a rule, we just say -1, -2, -3.
Okay.
4 plus, 4 minus, 3, 2, 1. As you can see right here with these carbon monoxide and carbon dioxide, this time carbon's a 2 plus because he's a 2 negative. But overall I have a -4 here, so he has to be a 4 plus. Make him happy. So yeah, we've used the parentheses with those guys who have multiple playing cards. Magnesium always plays a +2. So I don't need to say that he's playing his +2 card because it's his only card. Copper has multiple cards in his hand. I want to know which one he's playing. He's playing his number 1 card.
Okay.
Which tells me I only have 1 iodide.
Okay. That makes sense. So tin and bromine, they are both, well, it's like right on the borderline.
So you have S
Is
and...
tin's a metal, so bromine is a non-metal, so it's ionic.
Yeah. Do we know tins?
Yeah. It's
Off the periodic table?
3? Oh wait, no, we don't.
Under the line.
No, we don't.
We don't. This means we have to figure out from bromine. So each one's a negative, 2 negative, 2 positive. There's only one of them. 2 positive, right? So let's state the cation's name, his charge, since he's in transitional, and just bromide.
So H NO2.
So this is an acid, right?
Yeah.
So the hydrogen in the front.
You do that.
So acids, we have to look at what the base unit is. And if the base unit is, you can have 3 different options. It could be an ide, the base unit. It could be an ite, or it could be an 8 for the ones we're dealing with. If it's ide, hydro, that base part, ic, acid. If it's an ite, it becomes the base with an us at the end. We kick off this part of the base unit and put and then 8 becomes the base unit with ick at the end.
So since NO2 is nitrite,
Mhm.
which is that, so then it's nitrous
Acid, yeah.
acid.
Yeah. Any others on there?
No, but I want to go over more of those. Oh, there's a bunch of right here.
Okay.
So H2SO4.
H2SO4, you said?
Yeah.
Okay, so here's the base unit.
So
What's his name?
Sulfate.
Yeah.
So sulfuric acid.
Yeah. So is sulfur and phosphorus, they want to get the R's back in for some reason, so it becomes sulfuric, sulfurous, phosphoric, phosphorus instead of
Phosphorus.
I don't know, phosphite, you know, phosphorus. Maybe it just sounds better, phosphorus.
Sounds very dangerous. Acid. Careful. So then I haven't, let's see, I didn't do HNO2, so that's nitrite.
Mhm.
So then, oh, we already did that.
Nitrous acid.